When you think of a volcano, you probably picture a huge, fiery mountain on land, right? Well, in this explainer, we're going deep underwater to look at what happens when one of those giants suffers a truly catastrophic failure. Let's dive in, because this is one of the most spectacular and, frankly, terrifying forces of nature on our planet. So this is the big question. What actually happens? And we're not talking about a little lava flow or an ash cloud. No, we are talking about the entire side of a volcano, a literal mountain suddenly giving way and plunging into the sea. The consequences, as you're about to see, are almost beyond belief.
Okay, so to really get this, you have to change how you picture an oceanic volcano. It's not just a solid, static mountain. Over thousands, even millions of years, it grows, it swells, and sometimes it becomes incredibly unstable. It's basically a ticking time bomb, with immense pressure building deep beneath the waves.
The technical term for this event is a volcanic flank collapse, and it's exactly what it sounds like. One entire side, or flank, of the volcano just fails. It breaks off and slides away, triggering one of the single largest, most destructive landslides our planet is capable of producing. So how does this even happen? Well, it's usually a three-step recipe for disaster. First, you have magma rising from deep within the earth. It inflates the volcano from the inside, kind of like a balloon, pushing its sides outwards. Then other forces, the constant pull of gravity, a nearby earthquake, or even just extremely heavy rain, start to weaken that overstretched structure. And finally, you reach a critical failure point. A threshold is crossed, and the whole thing just lets go. And when that failure point is breached, wow, the collapse is unbelievably fast. This isn't some slow-motion geological process we're talking about. This is an event that unfolds in minutes, but it has the raw power to reshape a part of the world in the blink of an eye. The scale is just mind-boggling. A single collapse can unleash up to 500 times billion tons of rock and debris into the ocean. Now, to try and put that into perspective for you, that's like taking the weight of every single person on Earth and then multiplying it by 70. All of that mass suddenly sliding into the sea. In an instant, gravity takes complete control. A wall of rock, literally miles wide and thousands of feet thick, begins its unstoppable journey down into the depths. And when that colossal landslide hits the ocean, the impact is almost unimaginable. A huge volume of water is shoved out of the way in a fraction of a second. But here's the thing, it's not just a splash, not even close. The incredible heat from the volcanic rock and the sheer pressure of the impact instantly flash boils seawater into steam. This creates a massive, catastrophic explosion that injects even more violent energy into the event. And all that energy has to go somewhere. That moment of impact unleashes the ocean's fury, generating phenomena that ripple outwards from the collapse site with terrifying speed and power. Now, we've all heard of tsunamis caused by earthquakes, right? That's when the seafloor itself suddenly lifts or drops. But a volcanic collapse is different. It's not just lifting the water, it's displacing it. It's like dropping an entire mountain range into a bathtub. This creates something else entirely, a mega tsunami. The difference in scale is just staggering. A really big earthquake-driven tsunami might create a wave that's, say, 10 to 30 meters high. A mega tsunami from a flank collapse can be over 300 meters high near its source. Let me say that again, 300 meters. That is a wave as tall as the Eiffel Tower. And believe it or not, the wave is just one piece of the puzzle. The collapse also generates these incredibly powerful underwater shock waves. It creates boiling plumes of debris that can decimate marine life for miles. It can literally scour the seafloor clean, right down to the bedrock, and cause instantaneous pressure changes that are lethal to anything in the water. So, after all that incredible violence subsides, what's left? The event leaves behind a permanently changed planet. The aftermath isn't just about destruction. It's actually about the creation of a fundamentally new environment. The long-term impacts are really profound. Geologically, you've got a brand new coastline, a new bay, and a completely different seafloor. In the ocean itself, local currents can be rerouted forever, and entire ecosystems are wiped out, forced to begin a slow, long process of rebirth. And even in the atmosphere, those vast clouds of ash and volcanic gas can have a real impact on the climate. And this quote really captures the incredible paradox at the heart of all this. As absolutely terrifying as these events are, they are a fundamental part of our planet's life cycle. They tear down, yes, but they also build up. It's a raw display of how Earth reshapes and literally reinvents itself over geological time. So why does all this matter to us today? Because this isn't just ancient history. Many of these unstable volcanic islands are still active. And millions upon millions of people live along coastlines that could one day be in the path of a future mega tsunami. Understanding the warning signs is absolutely critical to protecting human lives.
And that leaves us with a pretty sobering thought. These incredible forces are not a thing of the past. Right now, scientists are closely monitoring active volcanoes in places like Hawaii and the Canary Islands. So the question isn't just what happened, it's where it might happen next. Which of Earth's sleeping giants are we watching today?